This video is sponsored by Astra Security, a service dedicated to helping you protect, remediate, and defend against known and unknown vulnerabilities in your environment. Sections with the Astra : will be in the timestamps below to highlight my thoughts. Learn more about Astra Security using the link in the description below. All right, so take a look at this code here. A classic, infamous SQL injection statement that allows you to bypass user authentication. SQL injection. At this point, this right here is a script kiddie example of a secure or insecure code and what not to do. Yet things like this or statements exist still to this day. Taking as an example the recent exploit on airport security, which allowed pilots and flight attendants to bypass the TSA checks as an example. So we all know that security matters. And trivial examples like these may seem, well, trivial, but they still are very important. And code is the gateway not only into the logic of how an application works, but how it can be exploited and taken advantage of to get unauthorized access or information. In today's video, I'm going to be overviewing why secure code matters, the fundamental principles behind what makes secure code secure or insecure, and we're going to be doing a little bit of this through examples with the Web Vuln Trivia game. Wow. Now, when it comes to secure code and coding in general, we have to think in terms of layers, starting from low-level machine code, which works on the processor, all the way up to your web application. In between, you have kernel, memory, OS level, network, software, and then you have maybe your web application layers. This is a very generalized layer approach, but today I'm going to focus just on one of those layers, which is the web application layer, because, well, we interface with the internet, and when writing pieces of code, there's a lot of working components. These components are often difficult to manage as a developer who's perhaps a little bit overburdened with priority and what they're supposed to be doing. This leads to the wheel of vulnerability. Play the game and win your prize of whatever vulnerability. Now, when you think about vulnerabilities, there's a lot of generalized types of web-based vulnerabilities. You have SQL injections, cross-site scripting, cross-site request forgery, IDOR, RC, LFI, remote code execution. So there's a lot of generalized types of web-based vulnerabilities, and this is because there are common mistakes made. Now, using the OWASP Top 10 as a great example of the logic behind why web vulnerabilities exist, a lot of application code has to do with configuration design and failures, and not really taking everything into account. The fundamental logic and design matter, and to abstract these principles, I'm going to be playing the web-based trivia game, explaining these 5 key principles for how to make your code secure. So cue Vuln Web Trivia. Now, before we do this, it's important to have visibility into your web application stack. You don't know what you have visibility into, and this is where a tool like Astra Security comes into play. Astra Security helps you gain visibility into your web application stack by continuously probing for and scanning your web stack. Now, after these scans have been completed, you can report on where that vulnerability or vulnerable code lies. But maybe perhaps you don't know if these findings actually exist. This is a common problem in the vulnerability management space. Well, with Astra Security, you actually get a way to provide vetted scans by human security experts going out and ensuring that you get high fidelity alerts or results on your scans. So if we go over to the vulnerabilities page up here on the Astra dashboard, and using this as an example of a test scan, we go to SQL injection, you're going to find some vulnerability details as you do for most vulnerability scanners. But if we actually go scroll all the way down here, what you're going to find is a cool little feature. You get to contact the security analyst and you can say, hey, can you please go out and vet or validate this as an actual finding, as well as you have your own little chat bot here where you can ask various different questions on this specific vulnerability that is affected in this asset. Now, in addition to just one singular vulnerability, we can actually vet an entire scan. So if we go to continuous scans here, you're going to see this automated scan, and we can request vetting of this entire scan. So we can ensure that, let's just say we have hundreds of vulnerabilities, which ones should our team prioritize? And Astra Security does that grunt work for you so that you can go out and patch those high severity alerts. So Astra just introduced a new dashboard platform called the Orbex platform here, and like I said, this helps you prioritize your vulnerabilities and ensuring that they're properly vetted by human security experts, not bots or some automated script. It's real people. When it comes to provisioning a new scan, we can go to continuous scans, start a scan. You'll see 4 respective types here. Now, when it comes to your passive approach, you can actually create a daily or weekly, whatever type of scan you want, whether that's a full credentialed scan or a lightning scan, that is completely up to you. Navigating to integrations and then CI/CD integrations, you're going to see some available integrations with various CI/CD tools. Now, one problem is oftentimes code is pushed out to production, and then it's a matter of trying to reactively find vulnerabilities after they've been pushed. Well, with Astra Security, it's a cool little integration here, the so-called shift left. You get to scan your vulnerabilities in your dev, QA, prod environment before you actually go out and push to prod. And this is all seamless through Astra Security's scanners here. Now, a tool like Astra can do ad hoc scanning based on demand, or you can go out and build your own automated workflow with these CI/CD integrations. It also provides a lot of other integrations in addition. So more on Astra Security here in a few moments with their proactive approach to secure code. Let's start out with principle number 1, which is input validation. Here is an example of a classic cross-site scripting vulnerability where you basically are able to treat input as trusted. And that's all about what input validation is about, really. It's about ensuring that you never trust explicitly input from users. You always do sanitization on your backend to ensure that you are getting the right input, and if there is malicious input or some sort of other input, you do proper error handling. So this, like I said, is a classic cross-site scripting vulnerability. If we go to the browser here, what we can see is a user would be able to basically write whatever they want arbitrarily, and it would store that rather than sanitizing that input. So if I do the classic script alert attack, it actually won't work because I'm actually not running this JavaScript file, but this will get executed and it will allow you to run JavaScript code when really you shouldn't be doing that. So input validation is all about ensuring that you're not trusting user input. Now, in terms of remediation here, I've copied the secure way of doing this. And really what you want to do is ensure that you're escaping with input sanitization. So basically, you are not treating anything as literal. And you can do this by using escape characters so that when a user puts in the script tag, it's just going to treat it as literally script rather than a function that of script. So the key to input sanitization is escaping or ensuring that you are properly handling these strings. Basically, one way to do this is just throwing it in all into one particular data type of, let's just say string, and you can do some additional parsing from there. All right, so principle 2 has to do with user authentication on authorization. Oftentimes, users are granted perhaps something that they shouldn't be doing. Now, to explore this, we'll just use a very simple Python program. All right, so here is a Python program which simulates a quote-unquote login panel. So this would actually be hosted out on HTML, an actual web application, but because I'm lazy, I'm just going to do it here on the terminal. So basically what I have here is, let's just say you have an application that takes a username and password, and I have this default user role with a user pass as the name. If I were to, let's just say, go ahead and log into this application, which literally is just going to be principle2.py, you're going to say, oh, welcome user, and then it's going to say accessing the admin panel. Now, why is this? This is a very trivial example and almost comically bad. So how this works is basically, we have a user, right, that has the role of user. But if the admin exists, then we'll go ahead and grant that the admin role. So what this function is doing is there's no authorization. So basically, it's not checking to see what type of role the user has. And so user 1 can access the admin portal because it has improper permissions assigned. So when it comes to authorization and authentication, some things you need to think about, really 2 things. One is the principle of least privilege, ensuring that your user has as minimal privileges as possible, especially if you're creating new users in a web application. Just give them baseline permissions. You don't want to have roles that are very permissive. So principle of least privilege. The second one is to ensuring that when you are authorizing roles, if you're checking in, for example, a role, you want to ensure that you're checking against those proper permission scopes. And so that kind of relates back to my point one. But basically, again, very trivial, but ensure that you have proper authentication and authorization in place. Again, kind of bad example. The third principle is very important, and that is prepared and parameterized queries, especially when you're interacting with SQL databases. So how does this work? Here, this is a simulating a quote unquote login form. Again, this is perhaps something that is very trivial, like as in, you don't really see this out in the wild as much anymore, but it still happens. So basically what happens here is the vulnerable login is where it treats everything as trusted code. It kind of goes back to that input sanitization. So what you're able to do here is create a statement where you could add in the admin and then do a -- which would simulate a comment, and it would comment out the rest of the query, including the password check. And so what this would do is the user could add in, basically admin, and then the password would be anything. So if we do Python 3 principal 3.py, so by inputting something such like this, it's going to comment out the password check, and you are able to log in successfully because, well, you don't have parameterized input. So the secure way of doing this would just be adding a parameterized statement, and you'll see this often nowadays. This is a well-known practice when you're working with SQL databases. So basically, you're passing those inputs as parameters rather than explicitly trusting the user input. This query is safe because the user input is treated as a string, not actual literal SQL executable code. And so this will allow you to not trust the user input and basically create the whole idea of a string type. It's a well-known practice, parameterized input, but it's, again, something to be aware of. At this point, very trivial, but it's important, once again, to not trust user input. Principle 4 is error handling. When an error occurs, you want to make sure that you are properly handling that error. And if you don't do that, well, unintended consequences can happen, and, well, of course, hackers can exploit that. So let's just see, again, a very trivial example of how this would work. Okay, so I'm on WSL here. I set up a Node.js environment, and basically what this is doing, this is a ChatGPT script. I will say that. So basically what this is doing is simulating an error. All right, so running this here, if we go to my browser environments, we go to user 1, you're going to see this error. What this would allow you to do is gather information, and perhaps you can use that information to find a different, like you can find a path, you can find perhaps some services that are running on the web server that may be exploitable. And so you never want to send error messages. You want to send very generalized error messages to your users, something like, oh, this couldn't work out. And you want to have verbose logs at the back end where only authorized users are able to actually see those logs. What you would do to secure that above code is something like this, just providing a very generalized message at the end of the statement, and you log on the server side because then you have authorized users who can actually see what's going on. So very basic example. So principle 5 has to do with encryption. In fact, we still see downgrade attacks or a lack of encryption on various data stores, databases, and we are seeing a much more expansive offering of encryption protocols today, our default decryption or encryption. So using an example again, principle 5 here, this is a very basic example where we can store some credit card information. Like you would actually do this in real life? Of course not, no. I've ran this application here. I'm having a curl request, which is going to upload a username and credit card information. So if I do this, You're going to say, oh, it's stored successfully, and it shows you the data. Wow, really cool. No, I'm really joking, but this is just like a dumb example of what you would actually do. So you wouldn't do this. You would store this information in either a hash or encrypted. It depends on the type of data, but you definitely want to have some sort of encryption, especially applied to sensitive data like credit cards. If you're running a production-based web application, you want to ensure that you're frequently looking at that algorithm, ensuring that you have the most up-to-date one that is, of course, production stable. But you see oftentimes out in the wild, people will write some open source code, they'll use an outdated library, and then that can be used to either employ downgrade attack or do some various other types of attacks. Looking at these 5 examples, you're gonna be like, dude, these are script kiddie examples. And honestly, yeah, I use ChatGPT to generate some of these, and I'm trying to show the basic constructs of how you would apply, but I realize that this probably is butchering the whole idea of insecure coding. So Script Kiddie 101, that's what this channel usually is all about anyway. Now on to another cool offering of Astra. Now, in order to effectively test and secure your web applications, it's important to have both a passive and proactive testing approach. Oftentimes, when it comes to proactive testing, companies will look at or engage in vulnerability penetration testing, where a team of outside pen testers will come in, they'll scope, assess, and exploit vulnerabilities to achieve maybe administrator access, and then provide that with a report of how they did it. So in addition to Astra's continuous scanning and vetted security scans like we overviewed, Astra actually provides an active vulnerability penetration testing engagement. So each year you actually have a team of professionals that go out and attack your web application, and this is entirely included within your subscription. So you get both the proactive and the passive approach of vulnerability scanning, and this is one of the reasons why I've partnered with Astra, is that they're very transparent with their pricing model. Okay, so on the Astra dashboard, if we navigate to the manual pen test, of course, I'm not going to engage in an actual pen test, but Astra will actually go out, they'll scope, they'll either do a white box, gray box, or black box pen test, depending on your needs, and you can engage with the team. Here will be the findings on the dashboard, all, like I said, in one unified area. Once that pen test has been completed, if we go to the vulnerabilities page again, and let's just say, for example, the pen tester found this SQL injection on your account or web stack, what you can do actually is, like I said, you can use the chatbot feature here to look for ways to either reproduce or how does it impact, and you actually can navigate or chat with the security analyst, the pen tester who perhaps found this vulnerability, so you can get more details on how this happens. As I said in the previous Astra section, we have different types of scans, and for the manual pen test, we can actually go to start a scan, manual scan, and that will engage the pen test team here. And like I said, they'll their findings here, and you can see the vulnerabilities that they find. So this is pretty cool. And another fun little feature that I have not seen in a security tool yet is if you go to like a SQL injection, you can actually see the bounty loss, which of course it's going to be variable in terms of what it's actually going to cost you, but it's nice to see what kind of impact each of the vulnerabilities would have. You know, those medium or high level severity impacts, P1s, of course, are going to be more severe and cause you more loss. So nice little feature on Astra. To learn more on Astra Security, I've just scratched the surface with Astra's Security's offering with that proactive and passive approach to vulnerability testing. Use the link in the description below if you're interested as a security engineer, maybe a manager as part of your business, for getting a curated step-by-step way to actually vetting vulnerability scans today and really securing your web application stack. So secure code, it matters, and oftentimes we're quite myopic with the way that we look at our code. As long as it runs, we're good to go, but that's perhaps not a great way of looking at it. So using these 5 principles, you can avoid a lot of potential vulnerabilities in your web application, and using services like Astra Security really help you with vulnerability visibility as well as remediation. So hopefully you've learned something new today. Secure code matters, and you know what it is. Until the next time, have a good day.